Good morning. My name is Mr. June. I'm going to be teaching you equations of motion and graphs of motion. Let me start with equations of motion. I'm going to make sure that I simplify these equations for you so that you use them to answer the questions that I'm going to give you below this video. The first equation of motion is V bar is equivalent to S over T. This is the first equation of motion where V bar is average speed in SI units meters per second, where S is displacement or distance in meters, okay? Where T is time in its SI units seconds. So from this equation, you can change subject to the formula to what you want to calculate, okay? Depending on what your question asks you to. For example, if your question asks you to find distance, it simply means you're going to have V is equals to S over T. And then for you to make a distance subject to the formula, you multiply by time both sides. So in other words, calculating distance given this, you're going to have S is equals to V bar times T, okay? So this one is for calculating distance, okay? Same applies to calculating time. You divide by T both sides, so which means you have S is equals to V bar times T. So if you want to calculate time, you divide by V bar both sides. Remember, V bar is average speed, S is displacement, T is time. So meaning time is equals to displacement or distance divided by average speed. So in other words, these are the main formulas. This is the main formula, and these are derived formulas, okay? You can derive two other formulas from the main equation, okay? So remember, when using this equation, all your units should be in SI. In other words, average speed should be in meters per second, displacement should be in meters, while time should be in seconds. Let's move on to the second equation, okay? The second equation of motion, equation number 2, is, do you know that average speed can be calculated as initial velocity plus final velocity divided by 2, okay? That's how you can calculate average speed, okay? So from this, so in other words, this is average speed. And then remember, from the previous equation, we learned that average speed can also be written as S divided by T, okay? From there, you can equate this to be equal to that, because these two equations simply means the same thing, they are equal. So which means S over T is the same as U plus V over 2. So from here, you can simplify this equation by multiplying by T here, multiplying by T there. So this T will cancel that one. So you're going to be left with S is equals to U plus V over 2 times T. This is the formula for calculating displacement or distance in meters given final initial velocity and time. Okay? This is equation number 2. Equation number 3. Equation number 3. So you already know that acceleration is change of velocity, okay? So in other words, acceleration is velocity 1, velocity 2 minus velocity 1 divided by time 2 minus time 1. In other words, acceleration is change of velocity over changing in time, okay? So, this is equation number 3. So, equation number 3 simply means that acceleration is final velocity minus initial velocity divided by time taken. So remember, what is V? V here is final velocity. And what is U? U is initial velocity. And what is T? T is time taken for that change of velocity. Time taken to change from U to V, okay? So in this case, from this initial equation, you can make so many other equations. The first equation, you can do this on time. Because of time, I'm not going to dwell much on that. So you can also have equation, you can deduce that V is equals to U plus AT. This is whereby when you are calculating what? When you are calculating final velocity, okay? This is for what? For final velocity. And then you can also deduce another formula, which U is equals to V minus AT. This is when you're calculating the initial velocity, okay? This is when you're calculating the initial velocity. Or you can make T subject to the formula or time subject to the formula. When you're calculating time, you can simply say V minus U over A. This is whereby you are calculating what? Time. Remember, this equation, for it to qualify or for it to be used, all your variables should be in SI. In other words, acceleration should be meters per second squared. I'm going to continue on another page. Acceleration should be in meters per second squared, not kilometers per hour squared. Final velocity should be in meters per second. Initial velocity should be in meters per second. Time should be in seconds. This is the only way this equation can qualify, okay? Without wasting any more time, I'm going to continue to equation number 4. Equation number 4, I'm not going to dwell much on how the equation came about, how to deduce the equation. I think I'll find some other time. I'll make a short video of how all these equations are deduced, or how they are formulated, or where they come from. But now I just want to introduce to you this formula. This is whereby you are not given time, yet you want to calculate your final velocity, your initial velocity, your acceleration, or your distance without given time. It's going to be V squared is equals to U squared minus plus 2AS, okay? V squared is equals to U squared plus 2AS. So this equation, you can make V several formula, so which means V is equals to square root of U squared plus 2AS. So which means this is for calculating what? This is for calculating final velocity, okay? And when you can come up with so many equations by simply changing subject to the formula. The first one is U squared is equals to V squared minus 2AS. So which means U is equals to square root of V squared minus 2AS, okay? This is when you are calculating initial velocity. Or you can also say equation number 2, sub-equation. These are sub-equation. The main equation is the one on top. You can also say acceleration is final velocity squared minus initial velocity squared divided by 2s, okay? Remember, A is acceleration, V is final velocity, U is initial velocity, and S is displacement. So which means this one will be used to calculate acceleration, okay? While the last one, the last sub-equation will be S is equals to V squared minus U squared over 2A, okay? This is when we are calculating what? We are calculating displacement. One more time, I want to emphasize that whenever you are using all these equations, make sure that your variables are converted to SI units, okay? And the main variables that we have here is acceleration in meters per second squared, final velocity in meters per second, initial velocity in meters per second, time in seconds, and average speed in meters per second. Thank you very much. Keep safe, stay at home, wash your hands. The next subtopic is graphs of motion. Stay tuned.